So in the last video we examined all the neighbors around the starting node, and we made sure that we wouldn't check any neighbors that were out of bounds of the map. In this video we will apply two other rules of the A-star algorithm. The first rule we will apply is the rule about adding all the neighbors to the open list. That's fairly easy. And the other rule we will apply is the rule about making sure that all the neighbors has a parent, and that parent should be the starting node in this case. So right now we only have the fact that we can click our starting point and our goal and press space, and then everyone turns blue because it's added to the open list. So we would like to do the exact same thing for all our neighbor nodes. So let's open the A-star script and then go to the function called getPath. Inside getPath we have these two if statements, and in here we have our neighbor. And this is exactly the neighbor we need to add to the open list. So you can make an if statement that says if the open list doesn't contain the neighbor. So if the open list doesn't contain the neighbor already, well, then we need to add it to the open list. So then we can say open list.add neighbor. So this will be executed when we run through all the neighbors. We have a reference to the neighbor here, and just to add it to the open list we add this code here. So now if we save this and jump back to Unity editor, play the game and click two places here and here, press space, then you'll see that all the neighbors are now added to the open list here. Now this hint why it doesn't really matter, but you can see here space and they're all added. But there's one problem here. The starting point is also added to the open list, so it's also blue. And when we start generating a bigger path, it can be hard for us to find the starting point because it also changes color. So to fix this, we can go back to our script and go to the A-star debugger. And here we can say if node.tileref isn't equal to start, I guess, yeah. Then we are going to do all this like so. If I could copy it correctly, there we go. So now we are only making the tiles that are on the open list that isn't the starting point. So if we play the game now, play it here and right click space, and then you can see start is not added to the, it is added to the open list but it's not blue. So now it's easier for us to find the starting position even though there's lots of blue squares around it. And right now I'm not going to fix this thing about changing the color because it's only for debugging. There's no reason to use energy and time to actually fix a bug here when it's nothing to do with the actual gameplay. We are only doing this to debug the path. So maybe we'll switch it later, but right now we're not going to do it. Anyway, that was the first rule we would apply for this content here. The next thing we're going to apply is the parenting of the actual tiles, because right now when we do like this, all the blue squares around here needs to point towards the green one, because the green one needs to be the parent of these squares, because that's where we found them, right? We used this one to find all the squares around here, and because we did that, well, then this is the parent. If we would have used this one, then this one would be the parent to all these. So to do this, we jump back to the script and we will have to go to our node. Inside the node we will need to do something so that we can set a parent. So make a property like so, and write let's call it node and call it parent, and make it a private set. We're only interested in setting it from this script here. Then we can make a new function because we need to calculate the g, f, and h values at some point. So let's just make a new function that does that and that also sets the parent for us. That will make it way easier, right? So we can make a public function returns nothing called calc values, and it will calculate values later. Right now it takes in a node, and this node is the parent. And then it says this dot parent equals parent. So at some point during the gameplay, when we find our neighbor and we need to calculate these values, we need to apply the next rule of setting the parent. Then we call this function here, and we tell the node what parent it has, so we will put in start here at some point. So the node knows that, okay, this is my parent, so we can backtrack later. So where should we do this? Well, we should do this from our a star function there. So after we add it to the open list, we can go out here, and then we can say neighbor dot calculate values current node. So the current node will become the actual parent of this this node here, this neighbor. Yeah, that's totally fine to do like this, because we used start. Start is our current node right now. We're running through all the neighbors. Every time we find a neighbor, well, then we will put our current node as the parent of this this neighbor here. We will do some more checking around here later, but it's not needed right now because we don't have the closed list. So don't worry, this line of code will also have an if statement around it at some point, so that it doesn't set the parent every time we look at a neighbor, because that will would actually mix up our root if we always set it as the current node as parent for every single neighbor, because it might already have a parent. That parent might be better. So anyway, now we are setting the parent, and if we save this, nothing is going to show up right here because we haven't added any functionality for showing the parent, right? If I do like this and play, then yeah, okay, I have all these nodes around it, but I don't have, I can't see which one is the parent. So actually, I would like to go all in and then just add an arrow to make these point towards the parent actually. So I have uploaded an arrow, and the arrow is actually in the description below. You can click that link to download the arrow sprite. I'm just going to pull this one from off screen if I could find it. Here it is. You have an arrow. Where is it? Debugging, and there's an arrow. Going to see if I can pull it in. Maybe I can't. Give me a sec. Let's try to pull it in here, and then go to Sprites. I'm so blind right now. There we go. And there we have an arrow. I'm going to make a new folder called debugging, just to put all the debugging sprites in it. So you can basically just add this arrow to your script. To your Unity project. Sorry, I'm mixing up my words here. So when you have the arrow that you just downloaded or created your own arrow maybe inside a folder in your tower defense game, you can take this arrow and add it to the scene by dragging it into the hierarchy. As you can see, this arrow is quite large compared to the actual tiles here. So we are going to scale it down by setting the pixels per unit to 300. And there we go. Then we are going to go to prefabs, and we are going to create a new folder called debugging. And inside that folder, we are going to create an arrow prefab. There we go. So when we have that arrow prefab, we can delete the arrow prefab from the game. And now comes the tricky part. We will have to go to our debugging script. So let's try to go to the a*debugger script, and here we have to make a whole bunch of if statements to make sure that this arrow actually works. So let's make a new function. Make a private function called point_to_parent. And I didn't hit my keys at all. Private void called point_to_parent. Okay. And it will take in a node, and it will take in a position. So as a vector 2. So the point here is the fact that the node here is the parent of the current type of the node we are looking at, so it knows where to which one to point at. And this is the world position, so we can turn it with the correct degrees, the right angles, right? Because we need to know if for example, if the starting point here, if we have this one up here, we need to know if the starting point is below it, and that's if x is lower and y is lower. Then we know we need to point this direction down here. Okay, so we can say game object arrow equals, and we need to get a prefab here, so let's go to the top, make private game object, call arrow prefab, and let's just serialize it so we can see it inside the editor. And then we can go down here and say instantiate arrow prefab. What is arrow? That's that one. Okay, arrow prefab at position, and we're not going to rotate it. Quaternion.identity. There we go. So this position is actually the position in the world we need to spawn it, of course, because we're going to use the node's position to figure out what direction it needs to turn. Right? If it's X is lower, then we go that way, and if it's Y is lower, we go down, of course. So the position here is used to determine where in the game world to spawn it, because we need to spawn the arrow on top of the node of the neighbor, and then turn it in the right direction by using this. And it's complaining here because we need to cast it as a game object. When you have done that, you can say make a lot of if statements here. If our node.gridPosition.x is less than the node.parent.gridPosition.x. Okay, so if the node we are spawning the arrow on top of, if that grid position is less than the parent's grid position, well, that means that we are to the left of the parent, so we need to point to the right at least. And then we need to say, let's just put this into parentheses to make it easier to understand. Then we need to say if the node.gridPosition.y equals node.parent.gridPosition.y. Okay, so if the node has the same y position as the parent, well, then we don't need to point up or down. So this if statement means we basically only need to point to the right. Okay, if that's the case, then we need to say arrow.transform.euler-angles equals new vector 3 0 0 0, and not animation, but we need to use arrow here. So this will make the arrow have a rotation of 0 0 0, which means it will point to the right because the x position is less than the parent's x position. So you can actually try to save this and jump into Unity, and then find your A-star debugger and see that there's an arrow prefab here, and then take the arrow prefab and drop up here, and then if you run the game, you'll see that there will be one arrow. If you click here and here, click, and it doesn't show because we haven't called the execute the function yet. Got ahead of myself, as I do a lot apparently. We need to call this function somewhere, and where should we call it? Well, we can actually call it in the function right up here. And basically, when we have tested this, we can go down here and say point to parent, and we can give it the node we are examining up here, because this for each loop is running through every single node in the open list. So we need to reset the parents there basically. So we say point to parent, we give it the node that we need to use to point, and then we'll need to say the node.tileref.position, good position, world position. So this is the node that we need to spawn at, or like point at and everything, and this is the world position of that node. Yeah. Okay. When we have done that, we can jump into Unity again, I guess. Let's try and run the game and click, and now it put it on top of the actual starting tile. That's not the case we want to do. Let's go back and see what we did wrong here. So we actually need to make a check here. I forgot to make a check. We need to say if our node.parent isn't null, because our start doesn't have a null, right? And we are trying to do something with the parent here. We are trying to node.parent, but start doesn't have this here, so it will give a null reference exception. So let's just try to do that if statement and put that in here. So now we are checking if we have a parent and our start doesn't have a parent, so all this code will work fine now, I guess. Let's try. Go again. There we go, and there we go, space. And then they all have an arrow pointing to the right. So, of course, that needs to be fixed, but right now they are all pointing to the right. And they don't need to point to the right, all of them, so we need to add some more functionality here. So let's just add one if statement at the time. We have this if statement here that makes them point to the right. So we can actually just write right over here. So it's easier for us to find the if statements. Then we can else if, basically, let's just copy paste this one. Take the top one, copy paste it underneath, and write else if. And we can call this one top right. Okay. So this is the top right one. And it needs to state that if the x is less and if y is larger, then we need to use the top right. There we go. And then we need to transform it. Well, if it's top right, then we need to use 45 degrees. Let's use 45 here. And let's try to save this and jump to Unity and see if one of the others do like this and this. There we go. So you can see this one, the parent is now top right for this one. So top, this is right and this is up. So this is top right. So now it's pointing towards the parent here. And let's see what else. We can make another if statement and we can take up. Let's just do up. And just copy paste the if statement above. And then we can say if x is equal to the other x and if y is larger than, well, then it's up. And then we need to rotate it 90 degrees. Oh, I just turned off numlock, so I just jumped somewhere in my code. There we go, 90 degrees. And then we save and jump back to Unity. Let's see if it points up, that one below it. Click, click, enter. Yeah, so now this one is correct, this one is correct, and this one is correct. So you can see they're all pointing at their parent. And we can copy paste this one more time. And then we have our top left. And if x is larger than the parent and y is larger, then it's top left, and we need to rotate 135. And let's save, jump to Unity. This voice is very redundant, but there we go. And here we have top left actually. It's not top right, it's top left. So it's pointing on this one. That's correct. Let's just write top left. It is top left, yeah. And then we have top right. Let's just copy this. We have top right up there. It's not top right then. I'm mixing these around. Let's see what this is instead. We have our x is larger and our y is equal. If x is larger, well then it's on this side and y is the same, so it's actually right side actually. So it should just be. Let's see. Try to save. Maybe I'm mixing these up. Sorry about that. Let's see. As long as it works, right? See here. Yeah. So this one is kind of wrong, but this one is right. This one is wrong. It points up here. Let's see what I did wrong. So what I actually did wrong was because I forgot to do this. I can say 180, and this one should just be named lift, I think. Let's try to call it lift. I think that's more suitable. And let's save again. Go, click, click, enter. Yeah, this one also points to the parent now. So now we need 3 more if statements. Yay. Let's copy this and paste it underneath and say that we want our bottom left. And on the bottom left, x should be larger and y should be less, like so. And we need to turn it to 125. Let's just take the others. Let's just say bottom, copy and paste. and then we can say x is equal, of course, because if we bottom, we're right underneath, so x should be the same, and y is less because we're underneath, and we need to turn it 270. And then we can copy paste this and right underneath at bottom right, x should be less and y should be less, and then we need to turn it 315. So let's try to save and play the game, and let's see, click here, and there we have it. So now all our childs are pointing towards their parent, and this will make it easier for us to debug the path along the way to see that everything works totally fine. So now you can see that all the childs are now pointing towards the parent, so we have added the parent correctly so far, because we only have one, so there's not that much that can go wrong right now. But later along the path you'll see that this will make more sense for us to have these child objects. So I am going to end this video here, so thank you very much for watching, and remember to like my Facebook page, follow me on Twitter, and subscribe to the channel. Also remember that InScope Studios is a community found page, so all your support is very important to me. You can support me in different ways. You can support me on the Patreon page, and if you do so, then you'll receive every single project that I've ever created for this channel, including all the assets and scripts. You can also get one of my projects as a standalone product by clicking the link in the bottom of the screen.